Okay, Bismillahirrahmanirrahim. So this is the question that you need me to explain. So figure 5.26 shows a designs for a toy balance that a manufacturer sends for safety testing. When water is poured into a plastic bucket, the pointer move over the scale. So if we look at the pointer there, it will move up or down. Okay, density of water is, this is pure water. Density of water equal to 1000 kilogram per meter cube. So again, this is topic under moment, which is moment equal to force times distance, okay, or principle of moment. Again, you need to recall what is mean by moment, what is mean by principle of moment. Okay, so let us look at the question first. A, when the total mass of a bucket and water is 1 kilogram, the beam is horizontal as shown in figure 5.26. So meaning horizontal, meaning it is balanced. Okay, calculate the force that the beam exert on the spring. So again, we tackle the A first. So we have the information there. The density of water is 1000 kilogram per meter cube, and then the beam is balanced, and then the mass, the total mass of the bucket and the water, the total mass of the bucket and the water is 1 kilogram. Okay, 1 kilogram. So how to tackle this question? So again, if we look closely at the diagram there is a force here, a bucket, downward force. There's the distance, this is also a distance, this is also force on the spring. So this is, straight away you will know it is principle of moment. So what is principle of moment? Principle of moment states that if a body is balanced, so in this question the beam is balanced, the sum of its clockwise moment is equal to the sum of its anti-clockwise moment about the same period. Okay, so again the formula F1 times D1 equal to F2 times D2. So again, bear in mind the force is the downward force, you need to change it into Newton sana. The distance you can leave it in centimeter because both of the unit is in centimeter. Whereas the distance, be careful with the distance. The distance is always from the force to the pivot. Okay, so the force here is sekali tadi anti-clockwise moment is equal to clockwise moment. So the mass of the total mass is 1 kilogram. Change it into force times 10 is 10 Newton. 10 Newton. Multiply by 20 centimeter equal to the force on the spring, okay, F2 times 5 centimeter. Okay, so F2 equal to 10 Newton multiplied by 20 centimeter divided by 5 centimeter. So equal to, you cancel 5, this is 4, so 4 times 10 is 40 Newton. So the force on the spring is 40 Newton. That's for A. Okay. Okay, part B, the bucket has a uniform cross sectional area of 0.012 meter square and a depth of 0.10 meter. Calculate the mass of the water needed to fill the bucket. So again, you are given the density here, the cross-sectional area and the depth. So I'm sure you will click it. What I mean is sudah tahu. So you are asked to find the volume first. Okay, so the volume equal to cross-sectional area multiplied by the height, so the depth of the bucket, so 0.012 meter square multiplied by 0.10 meter, so equivalent to 0.0012 meter cube. So this is the volume of the bucket. Okay, so now you're asked to find the mass. So again, you need to recall how to find the mass if you given the volume and the density. So this topic is under density. Density equal to mass divided by volume. Now you are asked to find the mass of the water. Okay, the mass equal to density multiplied by volume. So the density is 1000 kilogram per meter cube. So this is a pure water lah ni, times the volume 0.012 meter cube. So the answer is, if you use your calculator correctly, so 1.2 kilogram. So this is the mass of the water if you want to fill the bucket. Okay, that's it. Okay, for the last part C, without changing the spring, so the spring is the same, how can the manufacturer reduce the vertical distance moved by the pointer when there is a given load in the bucket? So again, the manufacturer don't want the light beam to move too much. Okay, move up too much or move down too much. That's what it means. The manufacturer reduce the vertical distance move. So here, I think there's a hint in the diagram why they are given plastic bucket of mass 100 gram. So you need to think about it. Fikir dalam-dalam tu. Kenapa dibaginya 100 gram tu? So, lihat soalan A tadi, part A. So, usually they will give a clue ataupun ada hint ada previous part of the question. When the total mass of the bucket and water is 1 kilogram, the beam is horizontal. So meaning it does not move, it stay at the same position, horizontal. The beam is horizontal, meaning balance. If this is 1000 gram, sorry, yes, 1000 gram, so 1 kilogram. So itu clue-nya. Okay, that's the clue. For me, that is the clue sudah. Okay, how can the manufacturer reduce the distance, vertical distance moved by the pointer when there is a given load in the bucket? So just change the plastic bucket, the mass of the plastic bucket into 1 kilogram, or you can use metal bucket, for example. Okay, as long as the mass of this bucket is 1 kilogram, that is the solution. Okay.